Why? Because it's el dia and la tarde. That's as far as I've gotten. I mean, it's like advanced stuff for me. Are we ready for the next one? All right. I don't know if there is a next one. We might only have one because, oh, that's enough. That's okay. That's enough for that one, right? Okay. Next thing. We're going to do little whiteboards pretty, just like, there we go, right? Keep us on our toes. The next thing is parsecs. And if you saw Star Wars, they used parsecs incorrectly. They talked about it as if it were time, but it's not. It's actually parallax seconds. And the seconds we're talking about are like 1 degree is 60 minutes, is 3,600 seconds, right? So each degree is like an hour's worth of time, right? And there's 60 minutes. Each of those 60 minutes is 60 seconds, right? Why did they do this? I don't know. Okay, this is, by the way, why GPS systems, they've given up trying to make people understand that there are 60 seconds to a minute, 60 minutes to a degree, right? And they've gone to this like UTM coordinates inside of this crazy grid, right? Do we know this? GPS, they mess with GPS stuff, right? So UTM coordinates are just so easy because it's all just, they have kilometer grids and you are, 800 kilometers over and, 373 meters up and there it is, right? Okay. Whereas, degrees, minutes, seconds, 57, are you halfway across that square or no, you're almost to the end of it, right? Because 57 out of 60, right? I don't know. It's very confusing. But this is the notion. When they talk about parsecs, this is what it is, right? And what parsecs is if there's a distant star, here's the Earth moving around. Can't we, instead of using the Earth as a baseline, can't we use the orbit of the Earth itself as it goes around the sun as a baseline? That's a heck of a baseline, right? This distance here is 2 astronomical units, right? And so some distant stars are bound to shift against the background stars, right? That's the notion here, right? And so if a star has a parallax shift of 1/3600th of a single degree, yeah? That's like not very much, right? But if it has that distance, has that much of a shift, then it's a distance of 1 parsec from us, right? Okay, so here's another picture, and apparently I got this off a French website, right? They have the sun and the earth and étoiles and les étoiles lointaines, right? The distant stars, right? Okay, and then I got this too. This is somebody else's image there, and I put the 2 images on top of each other. This is what they do. This is a photographic image of distant stars, right? And the first question is, why are the stars black and the space white? Is it a negative image? There you go, right? Okay, so this is it, right? And basically we've picked 2 points in our orbit, right? And maybe we're picking June and January, right? And here's the star right there, right? And what they do is they take 2 pictures of it, and if you watch, I'm going to toggle between 2 pictures, and you'll see that one of those things moves. And that's because it's closer to us, much closer to us than the other ones. You see that? You see the one that's moving? Yeah. Now, what you could do, or as they would say in academic circles, what you could have the graduate student do is, right, we know these 2 stars here are 0.52 seconds apart or something like that. I mean, we just know this. We know that is, right? And then we can measure this distance, and literally you just measure that distance. If that's 0.52 arc seconds, then that shift there was, 0.08 arc seconds or something like that, right? Literally you can just measure degrees as distance on this thing, right? And you can get that shift. This is the picture taken in January. This is the picture taken, in June. January, June. Okay, so let's do a little test here. Okay, everybody take your hand and put it out at arm's length. Hold your thumb up like this. Thumbs up. There we go. Okay, now cover your left eye. Now with your right eye, block something in the background. I'm blocking Connor Cheel's head. I'm squishing it now. Oh, just kidding. Okay, there we go. Okay, I'm blocking his head. Now, cover the other eye. Doesn't your thumb shift against the background of distant stars, or in this case, the room? Doesn't it? Do you see that? That shift is called parallax shift. Okay, now let's do an experiment. Let's move the thumb halfway closer to your head, right? Cover the same object. Okay, now cover your other eye. Shift back and forth. Some people can do it just like this. It's bigger, isn't it? Isn't the parallax angle now bigger? The bigger the parallax angle, the closer it is. Now put it like right here. Do the same thing. Cover up the object. Like, holy cow. Lots of shift, isn't it? Right, so here's the deal. Here's the deal. The distance in parsecs, and this is one of our formulas, like one of the few formulas, right? Okay. The distance in parsecs is 1 over the angle, the parallax angle in arc seconds. Right? This is the distance in parsecs. So for example, if it's 1 arc second of shift, a tiny amount of angle, the distance is 1 parsec. If it's half an arc second, then it's 2 parsecs away. If it's 1/4 of an arc second, then it's 4 parsecs away, right? If it's 100th of an arc second, then it's 100 parsecs away, right? That's how that works. And we'll do that, but let's practice concept 0. Concept 0 is that there are 3,600 seconds to a degree, right? And so let's practice this. So how many arc seconds are there in 3.2 degrees? Whiteboard problem. Whiteboard problem. Yeah, you got it. Now put the little arc seconds. Either label it arc seconds, right? 1 degree. You can either, if you want to live dangerously, label it that way, right? But most mortals just label it arc seconds, right? But that means seconds. This thing means minutes. Even minutes are minute. Hey. Spell minute, now spell minute. That's right. That's right. How many people have seen This Is Spinal Tap? Yes. In the movie This Is Spinal Tap, it's a rockumentary, and it's, who does it? It's Rob Reiner, isn't it? Rob Reiner does that? Yep. Yes. He directed it, yeah. And he's in it, isn't he in it? Yeah. Anyway, yeah, but label it with units there. In the movie, that's right, they're doing this heavy metal song about Stonehenge, because they're one of Britain's loudest heavy metal bands. That's right. Yep. Right. And he wants somebody to build. 3.2 though. But anyway, that's right. I think you got the right idea though. He wants somebody to build him a model of Stonehenge. Yeah? And he draws a picture for this person who's going to build it. He says, oh, Stonehenge is easy. It's these stones, and these have got to be, and he does inches instead of feet, right? That's feet. Stonehenge is 30 feet high, but he writes inches by mistake. So the person who makes the model makes the things 30 inches tall. Yes? This is a problem, right? And they discover it right before the concert that the model is 30 inches tall. So they hire a midget to dance in front of the model so that that it looks bigger, right? And then I don't know, you have to see the movie. It's called This Is Spinal Tap.
Where the demons dwell.
Where
the banshees live, and they do live well. Stonehenge.
Don't tell your parents that I recommended that movie.
Place.
Tell them that Mr. Duggan recommended that movie.
Where the moon doth rise.
Yeah. It's, yeah.
Something.
It's not as bad as Super Troopers, though.
It's hilarious.
It's funny. You got to see Spinal Tap.
My entire teaching career is based on about 20 jokes, and like 10 of them are from Spinal Tap. So.
It's true. So there you go. Yeah. Okay, next problem. 45 arc seconds is how many degrees? Figure out degrees. I uncovered a mystery.
A mystery.
I did measurements of the